Okay, let's do some math for fun. Here we're going to calculate sine of 10 degrees times sine of 30 degrees times sine of 50 degrees times sine of 70 degrees. And yes, we are using degrees. And also, if you would like, you can put down sine of 90 degrees, but that's just equal to 1, so it doesn't really matter, right? But anyway, you should pause the video and try this first. Okay, how did you guys do it? Alright, let's see. 10, 30, 50, 70. Yes, there's a nice pattern for that, so hopefully there's a way we can figure this out, right? And of course, I'm not going to use a calculator, otherwise you defeat the whole purpose of doing math. I don't think there's any good identity that we can use at the moment. I don't use the product to sum whatsoever identity. The only thing I know at the moment is that sine of 30 degrees is equal to 1/2, okay? But I don't know. I know we have the double angle identity and maybe the triple angle identity, right? That's a triple angle, but doesn't really help because this is not double angle, it's triple angle. So yeah. Let's write down the double angle identity on the side to see what we can do. We know that sine, because we're talking about sine, so let's use sine. Sine of 2 theta, this right here is equal to 2 sine theta times cosine theta, okay? All right, and then that's a double angle, but they are not twice of each other whatsoever. Okay, keep in mind, whenever we are sine, cosine should also come out to help us out, right? Whenever necessary. And this is about the co-function identity. So for example, if you're talking about sine theta, we can rewrite it in terms of cosine as long as the angles add out to be 90 degrees because they are the complementary angles of each other. That's a co-function identity. So when we have sine of 10 degrees, we can write this down as cosine of 80 degrees. 10 plus 80 is 90, okay? So this and that are equivalent. Likewise, let's do the same for this. I will write this down as cosine of 60 degrees. And then I will write this as cosine of, well, I can do 90 minus this, which is 40 degrees. And lastly, this is the same as cosine of 20 degrees. And now, when we look at the cosine version of this equation, 20, 40, 60, 80. Now, this is double. This is 2 times, right? Not really double, but from here to here is double. From here to here is double, okay? And I skip this because I know exactly this is 1/2, so I can care less about this, right? But yeah, this is double of that, this is double of that. And maybe I should write down the double angle formula for cosine, but no, because I will have to deal with a square, right? Cosine of 2 theta involves some kind of sine square or cosine square, right? Let's focus on this first. Well, I'm looking at this question in terms of cosine now, so let's isolate the cosine right here. And I can just divide this on both sides. So in other words, I can look at cosine theta is equal to sine of 2 theta divided by 2 sine theta, right? And now, here is the deal. Let's look at the first one right here, for example. 80 degrees, right? That will be the theta. And I will just plug in theta into here and here, and I will set up an equivalent form for that, okay? So this right here, when theta is equal to 80 degrees, I will plug in right here and here. On the top, 2 times 80, we get 160. So this is first sine of 160 degrees over 2 times sine of this angle. 2 on outside, and then sine of this angle right here, okay? And now let's do the same for all of them. Even though I know this is 1/2, but up to you guys. If you guys want to say this is 1/2, let's go ahead and put down 1/2. Why not? Okay, let's do this right here. Cosine of 40 degrees, that means theta is 40 in this case, right? 40, so I'll plug in 40 and 40 there. I will get sine of 2 times 40, which is 80 now, over 2 times sine of this angle, which is 40. Do we see what happens? This and that, haha, they are the same. We can cancel them out, right? But let's write this down first as well. 20 degrees, that's the theta now, so you know the deal. On the top is sine of 2 times this angle, which is going to be 40 degrees. On the bottom, it's going to be 2 times sine of just this angle, which is 20 degrees. Here is the fun part. Sine of 80 degrees and this sine of 80 degrees cancel each other out. Sine of 40 degrees cancel with that sine of 40 degrees. Okay, now what do we have left? Sine of 160 degrees and sine of 20 degrees. What can we do? Well, in fact, they are the same. Let me show you. Here is the picture for it. Remember, sine is the y value on the unit circle, okay? So if you just look at this right here, and let's say we have 20 degrees, this right here, okay? I know the picture is not perfect, but let's say this is 20 degrees. This right here, the y value, it's a sine of 20 degrees. Well, 160 degrees is exactly just like on the other side like that, okay? And the truth is, they will have the same y value. 160 degree means you go from here to here, and that's just a nice reflection of left and right, because the 20 happens to be right here as well. So this is sine of 160 if you look at the y value here, and it's the same height, same y value. So in another word, sine of 20 degrees actually equals to sine of 160 degrees. And the deal is, if these two angles add up to be 180 degrees, then the sine values will be the same, okay? If you want to see a identity, that's this one. Sine of theta is equal to sine of 180 degrees minus whatever the theta is, okay? But anyway, this and that can be cancelled as well. That's all I'm trying to say because of this. Okay, now, on the top, we have nothing but just 1. On the bottom, we have 2 times 2 times 2 times 2. Of course, that will give us 16. Finally, the answer is just 1 over 16. That's it. It's so much fun with all this, right? So, yeah, that's it. Hopefully you guys like this video. And if you're new to my channel, please subscribe and let me know what you guys think. And in fact, there's another way to do this, but I will save that for another time. But at the moment, that's it.